Welcome to another video in this channel, and this side I'm a Shafi Jami, and in this video we are gonna be playing a video in terminal. You heard it right. In terminal. We are gonna be playing a video in CMD terminal. So first of all we are gonna be going with an empty project and then just why your player and now we are gonna be making our project here, main CPP, and then include IO stream integer main and return 0 std cout hello. Let's see if we get this. So yes, as we can see, we have already got our hello. So this means our program is working fine. Now we are gonna be going to our project properties. Make sure that you have installed OpenCV. So we are gonna be going to our C++. Wait, let me just show you what we need to include and what we need to do. So in a new, here you can see this is my OpenCV installation folder. Then we are gonna go in C++, general and additional include directories. So in additional include directories, we need to give this include. We need to give it here. Then after giving this, we need to go to linker, general, and here I think additional library directories. So here we are going to be giving it again, go to your installation folder, and then this time also build x64 vc16 and then library. So give this to our additional library directories, and then in input having additional dependencies, give it our, like if you're using release, then give this name. Otherwise, give library name. Here, done. So this much we need to do. And now try to include OpenCV, uh, OpenCV HPP, and let's just make a CV matrix test, and let's see. So when we are gonna be running this, this is gonna give us an error. Have a look at this. DLL was not found. So for this, go to your working directory. Open Terminal File Explorer. Currently in VS default, my default is working directory is the project directory. So I need to paste this DLL. Wait. Come to your VC16, then bin and copy this DLL. Again, for debug, you need to copy DDLL, and for release, just copy this one DLL, this DLL. So here, copy this and paste, and go to 64 debug and paste. This was my working directory, so I pasted it here, and this was my really a debug application directory, so I pasted it here too. So let's just go to our working directory, and you can see I have already pasted the DLL. So now it should work. Here you can see our program has ended. So this means our program was successful. So right here we started with including two standard libraries. Then let me just paste this bit of code here. This is called the ASCII gradient. So for most bright, it is gonna give us at the rate, and for least bright, it is gonna give us just a space. So you can copy this from anywhere. I've just copied it from most probably Stack Overflow, and I'm gonna give it in comments. So make sure to just take it from there. So now we are gonna be making a new function, char pixel to AC ASCII. So here we would get unsigned unsigned char, unsigned character, pixel value, yes. And then we are gonna be getting our index is equals to pixel value into ASCII gradient dot size minus 1. And then whole should be divided by wait, did I do something like wrong? Index is equal to, yeah, and whole divided by 255. Yeah, this would be our what you say this function to get the index of it. So it would be our pixel value, which we would get from our brightness 0 or 255, like that. From our grayscale image, we are gonna get the brightness of a pixel, and then we are gonna decide the which index, which thing we need to have, and then we would just return ASCII gradient and ASCII gradient index. So it would we would just get a value of brightness, search it like, okay, so this is least bright, so our index is the last one, then just return this. This was our pixel to ACSI. So this function basically takes a pixel's brightness, 0 gets our black and 255 is the white, so and converts its position, then index, and then map to dense symbols. Dense symbols are these all light ones like this or space. So that's like that. So now this would be our cursor control function: inline wide move cursor top left. Then we are just gonna say std see out this thing. So this is the code for moving the cursor to the top left, like in this window, the top and left. Here, move the cursor here. We'd be using it in terminal. Then we are gonna go to our let's just test this. If we have got something wrong, let's just see. As I was sure nothing was wrong here. Then now we are gonna be removing this thing and adding a CV video capture cap video dot wait dot mp4. Then and if not cap dot is opened, then give us a error, std error error could not open vid file, and just have a new line here. Then let's just also see out this. So now let's just try this and wait. Return -1. Let's just see this. So right now it would be giving us an error that could not open video file. Error could not open. Oh wait, I did this 2 times. Error that we are not able to open a video file, and our program just ended with exit code -1. So now in our working directory, which is right now this, we need to paste a video. I have already got the video, and let's just paste it here. vid.mp4, vid.mp4. Let's just have a else statement, std cout video opened, video open, just video open. With this much, we are gonna go with it short. And let's see. We got our video opened. This means it has successfully read out our video. Now, we are gonna have, let me just paste a bit of code from my notes so that this video is short. Integer ASCII width, the characters per line. You can adjust this according to your terminal, according to how much um, big terminal you have. Then we get our aspect corrections. So since text character are not square, they are taller, they are wide, and it's like that, like they are taller than their width. So we apply a correction factor here, 0.55, to avoid stretched images. Then we calculate how many rows we can get of text are needed so the aspect ratio looks natural. We just get our video height, video height, then video width, and video height, and then video width. It's like that. Then we get our ACI. Width, we decide how many width we need, like this much width. But height, we need to like specify according to the video height, video width, and our ACI width. We cannot define it just like give it 100. We cannot do it because our video will just become squeezy or something like that. So we do like this. And then now we will have three matte, which would be our frame, resized, and gray. You would know why we need this. Then we just gonna see out this, and this is the ANSI code for clear the screen. Clear the screen. So we are just gonna clear the screen, and now at this moment we are gonna go to our main loop while while true, then do this. While true, if not capture dot read our video frame, we are gonna be reading it in frame, current frame, then break the while loop. Then now we are gonna be resizing a image. First, we would resize our frame. It needs an input array. So frame, then resized the output image that we need, output array. That we just take this and the output should be on the resized, and then we are gonna be resizing it to ACSII width and height. This is so much easy. Just take raw frame and resize it to ACSII, HEI, GHT, and width, and save it to resized pic. It's like this. It took a frame, took our width and height, resized it, and saved it in our resized. Now, so cap.read frame, this just reads the current frame of the video, while true, we just start the video, we just start reading our frames. Now, just have a look at this now. So now we use our move cursor to top left function here, and then we make our string output string and just reserve our ACII width and height. So reserve just tells the string that hey, I'm gonna need this much space, so allocate it now. So this is because like later when we try to put this, it would just take a lot more CPU power to just dynamically resize the string. So here we did our like ACII height and width is the total number of pixels in our video. So like in a frame, the height and the width would be our total pixels, like 150 by 150 total pixels into 20, because each pixel would contain some like what you say ANSI color escape code. We are gonna be having colored video on terminal, so it would have like some color code at the rate, then some color code, or some color code one, then some color code. It would be like that. Some code one code. It would be like in this way. So it's like that. So we are gonna be doing that. So that's why we gave it 20. It's usually it would be like 15 to 18 words, but just to be safe, we are going for 20. So it just like what do you say? It just reserved it. So now we are gonna be having a for loop. So for integer y is initialized to 0, y is less than resized image dot rows. So vertical direction of the resized image loops over the vertical direction of the resized image, vertical direction. And then we are gonna be having our second loop. As you know, an image has two like vertical, horizontal, like that. So first we are gonna be vertically, first line, do all this, second line, do all this, third line, do all these pixels. It's like that. Like have an example of this: 1 2 3 4 5 6. So go to first line, print all this, go to second line, go horizontally and print all this. So we got our y and x. So now we get our pixel color. We just get our pixel color. CV vec3 b color is equal to resized at CV vec3b x and y. So now just get our color at the point. So like first and first character, this is our pixel. So what is the color of that pixel? Just give me that. So it would return our BGR color. It would return a blue, green, and then red color. So let me just paste this comment so you can easily understand this. Like this. Um, blue, green, and red intensity. It's like that. So it would be like color 0 would be blue, color 1 would be green, and color 2 would be red. So now our pixel. So what is our pixel? Unsigned character pixel is equals to gray at our uchar. Gray at uchar x and y. So wait, did I just explain to you about what this did? This is just a CV dot convert color from the resized image. Take the resized image as the raw, and then the output image would be gray. So color is equal to blue, green, red to gray. Just convert it to gray. So it just converts at gray. So our gray frame is saved. Like take raw pick from resized and convert to gray and save to gray matte. So it just takes the resize, grays it, and just paste it. So now gray at what is the gray color? Like 0 to 255. 0 to 255, we get a value. What is the gray at X and Y? Then we just so much easy. We just get our ACSII char is equals to character is equals to our function pixel to ACII, and we just give our pixel. We just look here. We needed a pixel value, so 0 to 255. We got our pixel. So then accordingly we get one character from here. Then we already got this character. Then now comes the thing that you guys need to understand. This is it. Let me just make it a one line. Maybe you guys would understand it good. That's not the right way, but just for understanding it, we are gonna be doing this. So our output string that we had reserved, that string add, not nothing like, it's not like just a rewrite, override. It's like add 0322. It's the escape character for terminal control sequences 03203, and then we get our 38 and 3 38 2. So 38 semicolon 2 semicolon. Then we need to give our red, green, and blue values. So which is red, string color 2 is equals to red, comma, semicolon, then string 1, which is green. We need our green, then we need our blue value. So blue intensity, and it just gives our color dot zero. And then at last, we get our M. So, like for red color in terminal, it should be like R033 38 to 00255M. It's like that. Just this much is just you need to paste. Then it's you just need to paste this. Then after this you need to understand that after this you need to give your red color, green color, blue color, and at last add a M. This is it. Then at the last, like when we have already done everything, let me see, like new line. It's the new line character. So like when you have came to like just take this one. So just came to looping on this line. I printed this pixel, this pixel, this pixel, this pixel, this pixel. And now after the pixels have ended, I would go to a new line. So it's like that. After pixels have been ended, just go to a new line and then print other pixels. And then it's just like this much, and then we are going to be flushing this out. So let's just paste some comment there. So flush, what flush does? Flush just forces the buffer to be printed immediately rather than waiting it to fill. So like before filling it this much long thing, sometimes your processor may be like slow and it would not just do task very perfectly. So don't wait for it to fill, otherwise it would just become laggy and delays from buffering like that. Just print what you have. Like I need to print hello world. So don't wait for hello world to fill and then print. Just wait. Like you have done hello, just print it. You have done hello WOR, just print it. It's like that. Flush without STD flush, the OS might delay the input and your ACII video might appear choppy or late. Then we get our wait key. We wait key. um, break 10, and then we at last we release our memory, like so. The thing that we already have captured here, like video capture, we are just releasing it. We are sorry for that. We are just releasing that memory that we had just took here. And what about this, what we need to put here? So I need to give it the time delay, so it would take delay in milliseconds. 1 second have 1,000 milliseconds divided by 60. How much times you need to update? So like 1 second is equal to 100. Why is it like that? 1 second is equal to 1,000 millisecond, not 100,000 millisecond. So like we do like how much time we need to update? We give it 1 second divided by 60 times. So it would update 60 times, like 60 FPS. 60 FPS. It's like that, Mitch. So hopefully you understand all this. And let's just test it now. It's just a 75 line, 76 line code, 75, 76 line. And we got a error. Nice. I think you all just saw I got a error. Look at this error. This is because OpenCV match at this at function wants the row first, then column, and we just gave our column first and row after it. So it was this problem. We need to first provide our row at this row and then column. So here column. And now it would work, hopefully. Let's just see. So that was my problem. And let's just make it a full screen window. Look at this. And actually, you can see this much thing. So we can make it in use. So now we need to decide our width. 200 would be good for me. Let's just have a look at it. 200. Yeah, now you can just, according to your terminal, decide how much width you want. Just look at this cat, this rotating cat. So let's just try playing with it. 50. And let's just say a small video would appear. So there comes the thing that we needed to specify. We did not wanted to specify our height by ourselves. It's a small height would be accordingly. You all saw that. So my terminal fits 200 perfectly. So I'm gonna go for 200. Just full screen it, and here it came. So you can just see it is just a buffer. It just gets printed line by line. This got printed, then this got printed, this got printed, and it's like that. When we get our down, here it is. So that's it. We just turn a regular video into a colored ASCII animation using C++ and OpenCV. So if you enjoyed this project and learned something new, don't forget to like this video, subscribe for more coding tutorials, and drop a comment if you would like me to make more C++ projects like this on OpenCV or Qt or any other library. And most importantly, if you have any questions in any line of the code, just drop it down in comments and I would answer it. And thanks for watching this video. I'll see you in next one.